Hello everyone. So in this video we are going to continue looking at working with indices. So in the previous video we looked at how to multiply and divide expressions with powers, where when we multiply expressions we add the powers together, and when we divide expressions we subtract their powers. So in this video we're going to be looking at raising a power to a power. So by the end you should be able to multiply powers when raising a power to a power. This is rule 3 here, where we've got a to the power of m and we want to raise all this by a power of n. We basically just multiply the two powers together, m and n, to get a to the power of m n. So let's look at some examples. So the first one, we have x to the power of 7 and we want to raise that by a power of 4. So by looking at our rule, we know that to do this, we just multiply the powers together. So we're doing x to the power of 7 times 4. 7 times 4 is 28, so then we've got x to the power of 28. In our next example, we've got a to the power of -3. We want to raise this by a power of 4 again. So this time we're doing a to the power of -3 times 4. And that is equal to a to the power of -12, because -3 times 4 gives us -12. In the third example, we've got b to the power of -5, and we want to raise that by a power of -6. So this time we're doing b to the power of -5 times 6, sorry, -5 times -6, and -5 times -6 is 30, so then our answer is b to the power of 30. In the fourth example, we're doing 3y all squared. So we're squaring each of the terms in our bracket. So we're squaring the 3 and we're squaring the y. So then we've got 3 squared times y squared. Now 3 squared, we know that's 9. So then our answer will just be 9y squared. Then in the final example, we have 2x cubed. We're going to square this to x cubed. So we're squaring everything inside the brackets. We're doing 2 squared. And then we're also raising x cubed to the power of 2. Okay. Now I know that 2 squared is 4. Now when we're raising x cubed to the power of 2, we're just doing 3 times 2. So then we've got x to the power of 6. So then our final answer is 4x to the power of 6. So now we are going to look at filling in parts of our notes. So if you now go to your course notes on page 35, and it's section 10.2a. Okay, you can pause this video while you're doing that. So in your notes you will see a further 2 more rules. So rule number 1, 2, and 3 we've looked at in this video and the previous video. Rule number 4 is basically telling you that anything to the power of 0 is 1. Okay, so when your power is 0, anything to the power of 0 will always be equal to 1. And then rule number 5, anything to the power of 1 is itself. So for example, a to the power of 1 is equal to a. If you had y to the power of 1, that is just y. If you had x to the power of 1, whoops, that's the same as writing x. Okay, so those are your 5 rules of indices. So let's have a look at the 3 examples in your notes. First one, we're asked to simplify 2y cubed all squared times y cubed. So the first thing that we do here is we do 2y cubed all squared. Remember when we're squaring, we square everything inside the bracket. So we do 2 squared, that is 4. Then y cubed all squared. Well, we know that when we're raising a power to a power, we just multiply the powers together. So then we've got 4y to the power of 6. And then we've got times y cubed. Okay, so then the next line, in the next line we've got 4. Now because we're multiplying here, this time we add the powers. So this is rule number 1. Okay, we're doing so multiplying expressions with the same base for adding the powers. So then we've got 4y to the power of 9. Okay, our second example, we're asked to simplify k cubed bracket k to the power of 4 plus k to the power of negative 3. So before, the first thing that we do in this one is we need to multiply out the brackets. Okay, so remember when we do that, when we multiply out brackets, we multiply the term outside the bracket by every single term inside the bracket. So we're first doing k to the power of 3 times k to the power of 4 plus k cubed times k to the power of 3. Okay, so the first term here we got from multiplying k cubed by k to the power of 4, and then the second term here we're doing k cubed multiplied by k to the power of negative 3. So in order to do this, we look at our rules. So k cubed times k to the power of 4, well this is, we're using a rule 1 here again. So when we're multiplying expressions, we add the powers together. So then that will be equal to k to the power of 7. And then we have the second term, so we've got k cubed times k to the power of negative 3. So we're doing 3 plus negative 3, which is 0. So we've got k to the power of 0. Okay, we can simplify this expression further because we know that k to the power of 0, well, anything to the power of 0 is equal to 1. So k to the power of 0 is also equal to 1. So then we have got k to the power of 7 plus 1. Okay, so then in our final example, we're asked to simplify 3x to the power of 4 times 6x to the cubed divided by 2x to the power of 5. So that, again, the first thing that we do here is we work out the multiplication in the numerator. So we've got 3x to the power of 4 times 6x cubed. So we first do 3 times 6, which is 18. We then do x to the power of 4 times x cubed. So we're using rule number 1 here. So when we're multiplying, we add the powers. So 4 plus 3 is 7. So we've got 18x to the power of 7 over 2x to the power of 5. So we now have a division here. So we will be using rule number 2 to work this out. So the first thing we do is we look at the numbers. We're doing 18 divided by 2. That is equal to 9. Then we do x to the power of 7 divided by x to the power of 5. Now because we're dividing, our rule 2 states that we need to subtract their powers. So we're doing 7 take away 5. So then we've got x squared. 7 take away 5 is 2. So we have x squared. So then your final answer is 9x squared. Okay.